All right, let's look at an example, and I'll do the best I can to try and help visualize the algebra that we're doing, to visualize the conversion from datums that are in a unit to converting it to a unitless z-score. All right, so we're going to look at heights of women. So the heights of women have a normal distribution. Okay, we're dealing with height with a mean of 161 centimeters and a standard deviation of 7 centimeters. So question of part A is going to be, what is the z-score for a woman who is 170 centimeters tall? And how many standard deviations away from the mean is a woman who is 170 centimeters tall? All right, so first, let's make a picture of what we're looking at in a normal distribution. And then we'll make a picture using a standardized normal distribution. And that'll help us kind of expect what our answer is going to be. So we know that the heights of women is normally distributed. So what we're going to have is we're going to have a distribution shape, which is symmetrical and bell-shaped. I'm doing my best to just sketch this. Now, the center of the normal distribution is going to be at the mean. So that's 161 centimeters. Okay. That is actually, I think that's going to be a population mean there. So let me change the symbol, change it to mu. Okay. And we have a standard deviation of 7. So if we go one standard deviation up, that means we're going to add 7. So that'll give us 168 centimeters there. And if we go, so if I add 7, now to go in the other direction, if I subtract 7, then that's going to be 154. If I go another standard deviation up, I'm going to add 7 again, and that's going to give me 175. And if I go down, one more standard deviation, it's going to be 147 centimeters. All right. Now let's kind of draw a similar shape for our standard normal distribution. So the center of it is going to be 0. I'm going to draw the same bell-shaped symmetrical shape. And it's going to go 1 standard deviation above, 2 standard deviations above, 1 standard deviation below, 2 standard deviations below. So I want to point out a few things. First of all, our z-score of 0 correlates to our mean of 161, which is at the center. And then when we went 1 standard deviation above and 1 standard deviation below, that correlates to 1 standard deviation above and 1 standard deviation below. And on our standardized normal distribution, when we go 2 standard deviations above and 2 standard deviations below, that correlates to 161 plus 2 standard deviations above and 161 minus 2 standard deviations below. Okay. Now, we're being asked to find out what is the z-score for a woman who is 170 centimeters tall. So where is 170 centimeters on this normal distribution? Well, 170 is a little bit more than 168, and it's less than 175. Now, when we convert 170 centimeters to our standard normal distribution, we should expect it to be somewhere between 1 and 2 standard deviations above the mean. It should be somewhere between 1 and 2 standard deviations above the mean. So it's going to be some value that will be a little bit greater than 1. This is what we expect. So without having done any calculations, when we convert 170 centimeters over to a standard normal distribution, when we convert it to a z-score, we're going to expect our z-score to be greater than 1, but certainly less than 2, right? Because it's got to be somewhere right about here between 1 and 2 standard deviations away from the mean. So let's go ahead and do the calculation here. So again, let's always put down what our given information is. So we've got a mean of 161 centimeters, standard deviation of 7 centimeters, and our value of x is 170 centimeters. And to do the conversion, we need this formula. So z equals x minus mu divided by sigma. And now let's go ahead and substitute our values in. So x is 170 centimeters minus mu, which is 161 centimeters, all over sigma, which is 7 centimeters. Now, if we just worry about the numerator first, then 170 centimeters minus 161 should give us 9 centimeters. And that's going to be over 7 centimeters. Notice that the units now cancel, giving us a unitless number. And 9 divided by 7 gives us approximately a positive 1.29. So we get a z-score positive 1.29. Does this answer fit with our expectation? And you can see that it does. We expected the z-score to be greater than 1 and less than 2. And because 170 was just a little bit more than 168, we expect the number to be closer to 1 than it is to 2. And indeed, that's the case. So this would be the answer for part A. Part B is how many standard deviations away from the mean is a woman who is 170 centimeters tall? And the answer is 1.29 standard deviations above the mean. And that's the answer for part B. All right. Let me know if you have any questions.